So one of the things that's important to the hydrological cycle is the fact that all matter is in motion, and I'll try to explain what that is, why that would be. But all matter is in motion, and actually if we talk about the three physical phases of matter, those being solid, liquid, and gas, and I'm not going to necessarily animate this for you. Looks like I can, yep, I got the pen. I'm not going to animate this for you, but can you see that here's the solid and liquid, oops, liquid and gas over here. If I were to animate this, kind of going from left to right, solid to liquid and liquid to gas, what you would see are the particles moving faster and faster. So this is increase motion from left to right. And one of the things I think we talked about earlier is that we have this type of energy associated with motion called kinetic energy, or Ke. So as matter goes from solid to a liquid, or from a liquid to a gas, it's increasing its kinetic energy, it's increasing its motion. Conversely, I guess, as matter goes from let's see, where's my pointer here? As matter goes from, as I have it up here, from right back to left again, it is decreasing its kinetic energy. So gases go like this, liquids go like this, and solids go like this. Okay, that's called the kinetic molecular theory. All matter has motion. I know we talked about this because actually we talked about temperature scales, and we said that if matter has no motion, then if you were measuring, if you had a thermometer device there, it would be at a temperature of what we call absolute zero. So the other thing I need to talk about with regard to these three physical phases, solid, liquid, and gas, are these things called intermolecular bonds, and you're going to see them on the next slide. But solids, and sometimes I wonder which came first, the chicken or the egg. Solids don't have much motion. They kind of have what we call probably just kind of vibrational motion. But solids don't have much motion, and they're connected a lot. They have a lot of intermolecular bonds. Gases have a lot of motion, and they basically have no intermolecular bonds. So if I abbreviate IM, or intermolecular bonds, as IM, kind of from left to right, I am decreasing, DEC, decreasing intermolecular bonds. Okay, and it kind of makes sense. We're going to talk about something called latent energy, and when you take an ice cube, or let me highlight the solid over here. When you take an ice cube, right, how do you go ahead and make it liquefy? You add heat, and when you add heat, you break some of these intermolecular bonds, and plus your water molecules have more motion. So I just think that is so cool. Okay, so here's a figure from your textbook, and I'd like to kind of draw your attention to the top, and then we'll kind of move down to the bottom down there. Anytime you see these cute little red atom with two white atoms, that's an oxygen with two hydrogens. Those are Mickey Mouse water molecules, okay? And I don't know if you can see it, but these dots, okay, the little dot connecting the Mickey Mouses, those are the intermolecular bonds. And actually the way it works is the water molecules kind of connect alternating. An oxygen of one will be what we say partially negative, and it will go to intermolecularly bond with the hydrogen of another atom. Okay. Now, draw your attention to two physical phases. Here we have solid, okay, and here we have water as a liquid. Yes, my cat's not very happy over there. She'll be fine. So if you can see all of the intermolecular bonds over here, it might be kind of hard to see, but you see actually, and I don't know, we'll talk more about snow and the crystalline formation of solid water, but we end up with this kind of this six-sided, it's a beautiful thing. Okay, so there's water in its, what we say, its solid state. If you add heat, now notice what we're doing is basically we're breaking some of those intermolecular bonds. If we add more heat to liquid, what do we get? If you add more heat to liquid, you get a gas. You basically break all of those intermolecular bonds. So if you compare the intermolecular bonds over here as water is in its liquid state, we have some intermolecular bonds, some dots between the water molecules, but there are fewer than when water was in its solid state. So we're going to be talking more about breaking these bonds, these intermolecular bonds, to change phases, and quite honestly, forming intermolecular bonds. Like, for instance, when something goes from a gas to a liquid, some intermolecular bonds are formed. When something goes from a liquid to a solid, even more intermolecular bonds are formed. So we'll be talking more about that.